Hi there. Now in this tutorial I want to show you how we do algebraic long division. I've got an example here which I'll show you how to do, and then maybe you might like to have a go at this one. But before we can do something like this, I want to take you back to basic division with numbers so that we can understand the methods involved. So I've got this one here, divide 63,210 by 5. Now one way of doing this would just be to do 5s into then 63,210. Now if we're doing it by short division, we'd do something like 5 into 6 goes once, because once 5 is 5. And that leaves us with 1 left over. We'll put that against the 3 to make 13. What do we multiply 5 by to get as close as we can to 13? It's going to be 2. 5 2s are 10, and that leaves us with 3 left over. Put it against the 2 here to get 32. What do we multiply 5 by to get as close as we can to 32? It's going to be 6. Okay, 6 5s are 30, that leaves us with 2 left over. What do we multiply 5 by to get as close as we can to 21? 4, because 5 4s are 20. That leaves us with 1 left over. What do we multiply 5 by to get as close as we can to 10? Well, it's exactly 2. Now, not too difficult, I hope, but I want to show you now how we can set this out by a different method. Same answer obviously, but the method we're going to use is long division. And so we'll do exactly the same sum. We'll do 5 then into 63210, 63,000 then 210. So running through this again, we say, what do I multiply 5 by to get as close as I can to 6? Well, it's 1. Okay? But this time we do 1 times 5, which is 5, and put it underneath here. And we take away the 5 from the 6 to give us the remainder. I know up here we could see instantly that it was 1, but that's not the point that I want to make here. It's the layout. So 6 take away 5 gives us 1. And that 1 there was what we carried across to the 3 to make 13. But with this style, what we do is we bring down the 3 and we write it against the 1 to give us the 13. And we start again. We say, what do we need to multiply 5 by to get as close as we can to 13? It's going to be 2. So put the 2 there. And we now do 5 times 2. Or 2 times 5, obviously it doesn't make any difference, giving us 10. Okay, so put that underneath there. We now subtract to work out what the remainder would be. 13 take away 10, 3. Just as we had here. We carried that 3 across to the 2 to make 32. So we just bring down the 2 and we now have 32. And we start all over again. Now you might like to pause the video at this point and just carry on with this question. So I'll give you a moment then just to do that. When you come back, you can check your work solution against mine. Okay, welcome back. Let's see how you carried on with this. So we just say, what do we multiply 5 by to get as close as we can to 32? Well, it's going to be 6. So we just do 5 times 6, which is 30. We take away to find out what the remainder would be. So 32 take away 30 is 2. Bring down the next digit, which is the 1. Bring it down to the 2 to make 21. What do we multiply 5 by now to get as close as we can to 21? It's 4. So we do 5 4s are 20. We now subtract again to work out what the remainder is. 21 take away 20 is 1. bring down the next digit, which is the 0. That gives us the 10. What do we multiply 5 by to give us the 10? It's 2. Don't forget to finish off here though. We do 5 times 2, which is 10. We take these away from one another, and that gives us the remainder, which is 0. Okay, same answer obviously as we had up here, but a different style. Okay, it looks a lot longer, but we're going to need this style now when it comes to handling these kinds of questions, if we're to do it by algebraic long division. So we'll just border that off there. So let's have a go at this one here. Divide x cubed minus 5x squared plus 8x minus 4 by x minus 2. So let's just put this down here then. We're dividing the x minus 2 into all of this polynomial here. X cubed minus 5x squared plus 8x minus 4. So, as we did before for this one, remember we said, what do we multiply 5 by to get as close as we can to 6? Well, it was 1. Well, with this type of question, what we do is we take the x and we say, what do we multiply x by to get x cubed? And that has to be x squared. So write that up there. And then remember, over here we did 1 times 5, and we wrote the answer down underneath here. Well, in this one, we just do x squared times x minus 2, and we write the answer underneath here. So x squared times x is going to be x cubed, and x squared times minus 2 is minus 2x squared. When we had done that, we subtracted to find out what the remainder was. So again, we now do exactly the same. We subtract. We've got to take care over this though. We've got x cubed minus x cubed, so that's 0. But here in this column we've got minus 5x squared minus 2x squared, which is minus 5x squared plus 2x squared, which comes to minus 3x squared. Okay, so that's our remainder. And then, like in this example, we brought down the next character, the 3. Okay, well, we bring down the next value, which is the 8x. So bring that down there, write it in against the minus 3x squared, so we've got plus 8x. And we start all over again. What do you multiply the x with to get minus 3x squared? Well, it's going to be minus 3x. So write that up there. And now we multiply minus 3x with x minus 2. So minus 3x multiplied by x is minus 3x squared. And then we've got minus 3x times minus 2, which is going to be plus 6x. We now subtract to find out what the remainder would be. So we've got minus 3x squared minus 3x squared, so that's 0. And then we've got 8x minus the plus 6x. 8x minus 6x is 2x. And then what we're going to do is bring down the minus 4 and carry on. You might like to, again, just pause the video at this stage and finish this off. I'll give you a moment to do that. Okay, welcome back then if you did carry on with this. So what we do then is we bring the minus 4 down, so we just put that there, minus 4. And what do we multiply x by to give us 2x? Well, it's plus 2. 2 times x minus 2 gives us 2x now. 2 times the minus 2 is going to give us the minus 4. And if we subtract these, we see they're exactly the same. That gives us 0, no remainder. It also tells us that x minus 2 is what we call a factor of x cubed minus 5x squared plus 8x minus 4, because it goes in exactly. It leaves us with no remainder. Okay, well, I hope that's given you some idea on how to do that. So here's another example for you to try. Divide x cubed plus 9x squared plus 17x minus 15 by x plus 5. So again, I'll give you a moment just to pause the video. When you're ready, come back and you can check your solution against mine. Okay, welcome back then. See how you got on. So with this one then, I'd set up my x plus 5. We'll have x plus 5 here, and we're dividing then this into our polynomial of x cubed plus 9x squared plus 17x minus 15. So we just say, what do we multiply x by to give us x cubed? Well, it's x squared. X squared times x plus 5 gives us x cubed plus 5x squared. We now subtract to find out what that remainder is. So x cubed minus x cubed is 0. 9x squared minus plus 5x squared is 4x squared. So got 4x squared there. We now bring down the next term, which is in this case is plus 17x. So you've got plus 17x there. What do we multiply x by now to give us 4x squared? Well, it's plus 4x, so put that there. Now multiply 4x with x plus 5 and you get 4x squared plus 20x. We subtract to work out what the remainder is going to be. 4x squared minus 4x squared is 0. Now we've got 17x minus plus 20x, so that's 17x minus 20x, which is minus 3x. We bring down the next term, which in this example is minus 15. So what do you have to multiply x with to get minus 3x? Well, it's minus 3. And if we finish this off by doing minus 3 times x plus 5, you get minus 3x minus 15. And again, subtract to work out what the remainder is. And we find that we get minus 3x minus minus 3x, which is 0. Minus 15 minus minus 15 is 0. So there's no remainder. And so that tells us as well that x plus 5 is a factor of x cubed plus 9x squared plus 17x minus 15. So I hope you've been able to follow my methods here. Now in the videos that follow, I'll show you how to handle further ones like this, where certain terms in our polynomial are missing, how we lay them out. But essentially, it still follows much the same kind of method.
Hi, now in this tutorial what I want to do is introduce you to what is called the factor theorem. And essentially, if you've got a polynomial, f of x is a polynomial, that's something of this particular format where we have an expression that goes down in descending powers of x. Something like these two examples here. Here we have a polynomial of degree 2, as we say, where the highest power here is 2. And this one is a polynomial of degree 3, because the highest power here is 3. Now if you have a polynomial, f of x, and let's just suppose that the polynomial can factorize. Take for instance this polynomial here. It does factorize. It factorizes to two factors. One of them is x minus 4 and the other one is x plus 1. Two factors then. Let's just put those factors down. So the first factor was x minus 4. So x minus 4 is a factor. And we've got the other factor was x plus 1. Now something special happens when you've got factors. If I was to let x equal 4 in this expression, then what we've got here is that for this first factor, 4 take away 4 would give us 0. This factor would come to 5. 4 and 1 is 5. But nonetheless, 0 times 5 would give us 0. So in other words, it follows that f of 4 would give us 0. And if I was to look at this factor, if I was to let x equal minus 1, we'd have minus 1 add 1, which is 0. This factor would come now to minus 5. Minus 1, minus 4, minus 5. We'd have minus 5 times 0, which would give 0. So when x is minus 1, we get 0. So in other words, f of minus 1 gives 0. Now we can reverse this procedure. We can say that if f of 4 equals 0, it follows that x minus 4 must have been a factor of f of x. And if f of minus 1 equals 0, it can follow that x plus 1 is a factor of f of x. We call factors like this linear factors. They have the format ax plus b. Linear factors then. Let's take this polynomial here of degree 3, often called a cubic polynomial. If you were to factorize this, you'd find that you would get a linear factor, x minus 2, multiplied by what is often called a quadratic factor, 2x squared plus 3x minus 4. Now I'm not expecting you to be able to factorize this at this stage. All I just want you to appreciate is that if you were to multiply these two brackets out, you'd get this polynomial here. But nonetheless, x minus 2 is a linear factor of f of x. We've got two factors here, x minus 2 multiplied by this other factor, 2x squared plus 3x minus 4. But the most important thing that I want to put across again is if we look at the linear factor, that is x minus 2 is a linear factor. Let's just put it here, x minus 2 is a factor. If we were to let x equal 2, this would come to 0. This factor here would be 0. 0 times anything would be 0. So if x is 2, f of 2 would give 0. So it follows that f of 2 equals 0. And again, we can reverse this statement, that if f of 2 equals 0, it follows that x minus 2 must have been a factor of f of x. So what I'm saying is, basically, in general, if we were to take any polynomial f of x and it was possible to factorize it with a linear factor, let's suppose that linear factor was of the form x minus p. So you had x minus p multiplied by some other factor. Alright, it could be another linear factor, it could be a quadratic factor, it might even be a cubic factor, and so on. Nonetheless, what we have got is essentially that in this particular case, x minus p is a factor, is a linear factor. And if we follow the idea that if we let x equal p, then p minus p is 0. 0 times anything will be 0. So it follows that f of p would give us 0. And if f of p equals 0, it follows that x minus p must have been a linear factor of f of x. And we can take this a little further. I mean, suppose we have f of x is identical to x plus q being a linear factor, being multiplied by some other factor. Then we can see that x plus q is a factor of f of x, And if you put x equal to minus q plus q is 0. 0 times this other factor will be 0. So it follows again from here that f of minus q must be equal to 0. And if f of minus q equals 0, it follows that x plus q is a linear factor. And it's this idea that is basically the factor theorem. So I've summarized it for you here, that if f of x is a polynomial and f of p equals 0, then x minus p is a factor of f of x. Or if f of x is a polynomial and f of minus q equals 0, then x plus q is a factor of f of x. And we can use this idea to help factorize polynomials, especially cubic polynomials and above. Okay? So I hope you'll look at that tutorial. Well, that brings us to the end of this tutorial on what the factor theorem is. Hi. Now in this tutorial what I want to show you is how we can go about factorizing a cubic polynomial by using the factor theorem, which we talked about in an earlier tutorial. Now before we start, if you get a question like this and it's not got f of x is identical to this, then I would always suggest that you put that. So let's start with let f of x. We'll define f of x as being identical to this expression here, this cubic polynomial, 2x cubed minus 3x squared minus 11x plus 6. If we do this, it just makes it a lot easier to present the solution. Okay. What we need to do now is to substitute values of x into here, and what we're trying to do is find some value of x which will make this 0. But I just want to give you a few tips before we start. Remember that when you factorize f of x, okay, let's just put f of x over here for the moment, it's going to consist of at least two factors, okay? One of them will be in one bracket here and the other one will be here. Now this particular polynomial has plus 6 on the end, and what we know is that there's going to be a number on the end of this bracket here and there's going to be a number at the end of this bracket here, and these two numbers are going to be multiplied together and they're going to end up giving you the plus 6. So what could they be? Well, if they're to be integers, then it could be a 1 and a 6, it could be, say, a 2 and a 3, and don't forget it could be minuses as well. So we've got quite a combination of numbers that we could choose. It'd be silly really to choose something like a 5, say. 5 times something else giving 6, well, okay, it's got to be 6/5, but I wouldn't really encourage that, okay? I would stick with the integers, like we have here. So, what I'm saying is then, let's start by trying, say, x is 1. And if you were to do f of 1, what we would have is f of 1 would equal, we would substitute x is 1 in here and have 2 times 1 cubed, minus 3 times 1 squared, minus 11 times 1 plus the 6. And if we work that out, what does it come to? It comes to minus 6. So it didn't come to 0. If it did, then x minus 1 by the factor theorem would have been a factor of f of x. Okay, so 1 didn't work. What you could try is, say, another value of x. Don't forget to try negative values of your x values. So in other words, try maybe f of minus 1. Well, if you do that, I'll leave it up to you to just try that, but if you do substitute x is minus 1 in there, you get 12, not 0 as we require. What would you do next? Maybe you'd try x is 2, so try f of 2. But if you did try that one, you'd find you get minus 12. Just check it out, okay? 2 didn't work, didn't give us 0, So what would you most probably try next? Minus 2, f of minus 2. So if we substitute x is minus 2 into here, you've got 2 times minus 2 then all cubed, minus 3 times minus 2 all squared, minus 11 times minus 2 plus 6. And if you work this one out, what you get here is minus 16 minus 12 plus 22 plus 6, and that comes to 0. So we hit the jackpot. That means that now that we've got f of minus 2 equaling 0, by this line here you can see that the q here corresponds to the 2, so it means that x plus 2 is a factor of f of x. So if we put that down, we've got that therefore x plus 2 is a factor. Now, once we've got that x plus 2 is a factor, once we've got one factor, we know then that basically f of x is identical to x plus 2 multiplied by some other factor. Let's just put a question mark there. Now there's several ways that we can get this factor. It's often called a quadratic factor in cases like this. This one's a linear factor, and then we need to multiply it by a quadratic factor, something that starts off with an x squared term, then an x term, then a constant. Now to get that quadratic factor, one way that we could do this is to divide both sides of this equation here by x plus 2, and that would give us the quadratic factor, the question mark in there. It would be identical to f of x divided by x plus 2. So what we could do to get it then is to do algebraic long division. That's one way, and that's the way I'm going to show you in this tutorial. In another tutorial I'll show you another way that we can get that quadratic factor. Okay, what we'll do is algebraic long division to get that quadratic factor here then. And so what we have then is, for the quadratic factor, I would always suggest that we write that in for the quadratic factor. Just gives the reader some idea what we're doing, hopefully anyway. Okay, so for the quadratic factor, let's put a line down there, section it off. I'm assuming that you're familiar with algebraic long division. If not, you can always go to another video on my website, look under the main index of tutorials for algebraic long division, or you might even see a link on this page if you're viewing it on my website. Okay, we've got to do x plus 2 then into f of x, 2x cubed minus 3x squared minus 11x plus 6 to get that quadratic factor. In the usual way, what do you multiply x by to give 2x cubed? Well, it's got to be 2x squared. Multiply the 2x squared then with the x plus 2 and you get 2x cubed, and 2x squared times 2 is 4x squared. Subtract to find out what the remainder is here. So you've got 2x cubed minus 2x cubed, that's 0, minus 3x squared minus plus 4x squared is minus 7x squared. Bring down the minus 11x, so just mark that in there, minus 11x. Start all over again. What do you multiply the x by to get the minus 7x squared? So that's going to be minus 7x. Put it up there. Multiply minus 7x with the x plus 2 and you get minus 7x squared minus 14x. Subtract to get the remainder. So do that. Minus 7x squared minus 7x squared is 0. So you now have minus 11x minus 14x, which is going to be plus 3x, or just simply 3x. Bring the 6 down now. Put it there. What do you multiply the x by to get 3x? And it's going to be plus 3. 3 times x plus 2 gives 3x plus, and 3 2's are 6. We've got an identical value here, so that when we subtract to find out what the remainder is, we get 0. And this proves also that x plus 2 is a factor of f of x because we had no remainder, it went in exactly. So here's our quadratic factor now, 2x squared minus 7x plus 3. So at this point then we can say that therefore f of x is identical to our linear factor x plus 2 multiplied by now our quadratic factor, which is the 2x squared minus 7x plus 3. And check out your quadratic factor. Quite often that quadratic factor factorizes again into two linear factors, and this one is no exception. It does. So we've got x plus 2, the first factor, and then this quadratic factor splits into two linear factors, and in the usual way just factorize it. We've got 2x and x giving the 2x squared. We need a minus 1 there and a minus 3 there. Minus 1 times minus 3 gives the plus 3, and you'll notice you get minus 6x minus another x, which is the minus 7x. So there you have f of x, or 2x cubed minus 3x squared minus 11x plus 6, fully factorized in three linear factors. It's worth pointing out at this stage, by the way, that just note, if you had got a question which said solve the equation f of x equals 0, you'd first factorize f of x, okay? And then once factorized we can say that each of the factors would equal 0, and that would lead to x equaling minus 2. For this factor, 2x minus 1 would equal 0. That would lead to x equaling plus a half. And for the factor x minus 3 equaling 0, x would equal 3. But we're not being asked that in this particular question. Okay, so don't write that down, okay, as the answer to this, because it wasn't an equation. It's just factorize it. But it's just in case it ever did say, as I say, f of x equals 0 and you had to solve it, they would be the solutions. Okay, well that brings us to the end of this tutorial on factorizing a cubic by using this particular method to get the second factor by using algebraic long division. As I said, I've got another tutorial where we can avoid doing this, and you might want to have a look at that one. Hi. Now I'm assuming that if you're watching this particular video that you are on my website and you've watched the previous one to this, and that was where we tried to use the factor theorem to factorize a cubic polynomial. This one here, 2x cubed minus 3x squared minus 11x plus 6. And what I showed you was that if we defined it as f of x and we tried various values of x, I chose x is 1, substituted in, we got minus 6. We're looking for a value of x that gives us 0, and we tried several other ones. F of minus 1 gave 12, f of 2 gave minus 12, but eventually we came across f of minus 2, which gave us 0. And by the factor theorem up here, it led us to the conclusion that x plus 2 was a factor. And I showed you that if f of x was identical then to x plus 2 times another factor, this factor could be found by dividing f of x by x plus 2, and we did it here. And it's at this point that I said to you that there was also another way that we could get this quadratic factor. So that is the purpose of this tutorial, to show you the alternative way. So what we'll do is we'll just remove this version here, and I'll talk you through the next version. Now what we have is then that f of x is identical to our linear factor x plus 2, which we've already discovered down here, and then we've got multiplied by another factor which is going to be a quadratic factor, something of the form ax squared plus bx plus c. Alright, now we've got to work out what a, b and c are, but it's not that difficult, because when we multiply this out, we're going to obviously multiply x with each of these three terms here and then follow it with 2 times each of these three terms. Now when it comes to the x cubed term, in this case 2x cubed, you're only going to get an x cubed term once from doing x times this term. X times the bx would give an x squared term, x times the c would give a x term, and so on. 2 times this ax squared will give an x squared term, 2 times the bx gives an x term, and 2 times the c gives a constant on the end. So the only x cubed term comes from x times ax squared. And that's got to be 2x cubed, so what must the a be? Well, it's got to clearly be a 2. So we could write a 2 in there. X times 2x squared, 2x cubed. Now the other easy value to establish is the constant c on the end, because the only way you're going to get a constant is by multiplying this number, plus 2, by the constant on the end here. So clearly, what do you multiply plus 2 by to get plus 6? Well, it's got to be plus 3. So the c there is going to be a 3. All it leaves us now to work out is the b value, the coefficient of x, as we say. And there's several ways that spring to mind that we could do this. We could compare maybe the x squared terms. Let's show you. If we were to compare the x squared terms, what are we going to have? Well, if we were to multiply this out looking for x squared terms, we're going to get one when we do x times bx. So we'd have bx squared. So there's going to be a bx squared. When we do x times the 3, well, that's going to be an x term, so we don't want that. Now when we do the 2 times the 2x squared here is going to give 4x squared. So that's an x squared term, so we're going to have plus 4x squared. But that's the only other x squared term, because 2 times bx would be an x term and 2 times the 3 would be a constant. So what do we know that this is going to be identical to? Well, we're looking for it to be identical to minus 3x squared. So minus 3x squared. So if we ignore the x squareds here, we can see that therefore b plus 4 must be identical, or in this case has got to come to minus 3. So to work out what b is, just subtract 4 from both sides, and therefore we have that b equals minus 3 minus another 4, which is minus 7. And you can see that then that would be minus 7x. We didn't have to compare the x squared terms though. We could have compared the x terms, and I'll run you through that one. Okay, if we were to compare the x terms, how would that have fallen out? Well, we've got, when we multiply the x throughout here, the only x term we're going to get will be when we do x times the 3. So it'd have 3x. And then don't forget we've got to do the 2 multiplied by the bx here. 2 times bx will give us an x term, 2bx, so that'd be plus 2bx. And what's that got to be identical to? Well, we hope that it will come to this x term here, minus 11x. So if we ignore the x's now, it therefore means that the 3 plus 2b must be equal to minus 11. And if we subtract 3 from both sides, we've got 2b equals minus 11 minus 3, which is minus 14. And if we divide both sides by 2, we end up with b equaling minus 7. Obviously it's got to be the same value as we established here, and you can see it works. Okay, so now that I found out what b is, I could substitute it back into here. Well, I'm clearly running out of room here, so what I'm going to do is remove this and we'll just carry on as I did earlier. So once you've got that b is minus 7, okay, we can just fill it in. So we'll remove this, and so we now have that therefore f of x is identical to x plus 2 multiplied by 2x squared minus the 7x plus 3. And As we did earlier, we factorise this quadratic factor. Sometimes the quadratic factor won't factorise again, but in this case it did, to two linear factors. One was 2x, the other was x, and we had a -1 here and a -3 there. Alright, so we've got f of x factorised now, and we did it by this particular method, avoiding algebraic long division. But leave it up to you. You decide which method you want to use. Hi. Now in this tutorial what I want to introduce you to is the remainder theorem. That's this theorem up here. And essentially the remainder theorem gives us a quick way of finding the remainder when a polynomial f of x is divided by something of the form ax minus b, where a and b are constants, and that remainder is given by f of b over a. And to demonstrate this, what I've got is an example here. Find the remainder when 4x cubed plus 5x minus 1, here's our polynomial, and it's divided by, in the first case, x minus 2, and in the second case, 2x plus 1. Now if ever you get a question like this, find the remainder when in something's divided by, say, x minus 2, it's very tempting to just divide x minus 2 into your polynomial by using algebraic long division. Something like this. Now if you do this, okay, algebraic long division, and by the way, if you're unsure of algebraic long division, you should find a link on the page that you're viewing this video if you're viewing it on my website, or if not, you can go on my website, look in the tutorial index for algebraic long division, and you'll get a tutorial showing you how to do this. So assuming that you're happy with long division, okay, then the remainder would be 41. So we'll just put that down, okay? But as I said, this is not really the best way of doing this kind of problem because it just takes too long. If we use the remainder theorem up here, we can get the remainder so quickly. I'll show you. All we need to do is, first of all, define our polynomial f of x. So what we'll just say is let f of x be equal to 4x cubed plus 5x minus 1. Now the remainder is given by, let's put that in, f of, now f of b over a. And when we compare x minus 2 to ax minus b, hopefully you can see that the a, the number in front of the x, is a 1 in this example, and the b, be careful here, is just the 2. We've got this minus here, so we've got the minus there, so b is 2. And so the remainder is given by f of b over a, so that would be 2 over 1, so f of 2. And you can get this value very easily just by putting this equal to 0. If x minus 2 equals 0, x would equal 2. And it's 2 that you'd put into here. So the remainder is equal to f of 2, according to the remainder theorem. And that would mean that we substitute 2 for x in here. So we'd get 4 times 2 cubed plus 5 times 2 minus 1. And what does this come to? Well, 2 cubed is 8. 4 eighths are 32, plus 5 twos are 10, that's now 42. Take away 1, 41. Our remainder here. So how easy was that? How quick was that? It's brilliant, okay? So well worth remembering the remainder theorem. Now in my next example, we're going to find out the remainder when the polynomial is divided by 2x plus 1. And again, you could do algebraic long division. Here we are, and again it's going to take you some time to do, to discover that the remainder here is minus 4, and I've written it out here. But if we've got f of x defined, then the remainder is just going to be very easy, because all we need to do is to take our expression 2x plus 1, think of it as equaling 0, so that would mean that 2x would equal minus 1, and then x would equal minus a half. So the remainder is given by f of minus a half. So all I need to do now is just substitute minus a half then into our expression here for f of x. So we're going to have 4 times minus a half all cubed, plus 5 times minus a half, and then minus the 1. And if you work that out, you'll find you get the remainder of minus 4. And again, so much quicker. Okay, well, hope that's given you an idea of the remainder theorem, and should be able to work out some examples now using that idea.